Okay, thank you very much. I'm very glad to be here and present the preliminary results of a joint project between our institution in Pisa and the Institute for Bulgarian Language from the Bulgarian Academy of Science. Okay, as Vito already prepared the field for me, my talk will address reading, which in psycholinguistics has been traditionally taught as a specific case of visual perception analysis and has been traditionally studied through eye tracking, a technique that allows researchers to keep track of the eye positions and eye movement with a millisecond precision. The main idea is that by looking at ocular pattern, we can gain insights into the cognitive mechanism that underlie reading so that the eye can be thought of as a proxy of the mind. As Vito already said, there is evidence for strong correlation between finger and eye movements. Here I'm referring to a non-reading related study that has been published in 2019 by Leo and colleagues on Nature Communication. Here, in this experiment, participants were required to deblur a blurred image by either fixating it on the screen, and the point of gaze was deblurring the image, or either fixating with the fingertip on the screen. And we can see that the attentional map, the places where it was more probable for the blur to happen, were pretty much the same in the two modalities. Therefore, like the finger somehow can be thought of as well as a proxy of the mind. And this paper, together with the evidence that we will see in a while, suggests that tablets can be used to collect finger tracking data in an easy, cheap, quick, and ecological way. Okay, the way we keep and start this kind of research was through the development of the Readlet app. Readlet, as Vito briefly mentioned, is an infrastructure that allows, through cloud computing, the administration of reading tests, and that allows for monitoring of the reading capacity in readers, adult readers, child readers. That's very up to the researcher, and it's a flexible application. The user endpoint is a simple tablet where the actual reading happens. As Vito already said, and we'll see an example in a while, the reader explore and finger track the text while reading on the tablet screen, of course, and the app is able to capture the finger movements speed while reading in real time. In oral session, the microphone catches the speech of the reader, and all the data are pseudonymized and transmitted through a secure connection to a central repository. Post-hoc, researchers can extract this data that refers to text processing, haptic processing, and speech processing, and analyze them to come up with query, data viewing, statistical modeling, and kind of data that can fed to machine learning and AI technologies. To show you a real example, I'm sorry this is in Italian, but our reader here is Vito's daughter, and we have no issue in the privacy of the reader, and I can show you how this is work. What? The audio. No audio.
Racconta storie. Mio nonno Andrea è molto bravo a raccontare le storie. Non racconta le storie della buonanotte. Il nonno Andrea non legge.
Of course, if you're not familiar with Italian. Okay. If you're not familiar with Italian, it would be tough for you to understand the text, but if we look at the screen, let me grasp the mic. We can see the different type of data that the tablet can grasp. Highlighted in blue is the tracked text. Here is the actual coordinate, XY coordinate of the finger. And the yellow rendering refers to the vertical alignment that find the best match between the finger trace and the line of text. While this small blue dot up to the word refers to where the voice is when pronouncing the words being read. And I hope this picture can represent pretty clearly the richness of the multimodal data that Readlet is able to acquire. Going to the actual experiment, our Bulgarian colleagues made a remarkable effort to collect more than 70 elementary school children from 2nd to 5th grade. The reading material was made up by 4 narrative texts that were counterbalanced across participants. Each text was made up by 5 chapters each that were originally written in Italian for the Italian version of the experiment, and again, with a remarkable effort, were translated into Bulgarian, keeping this structure, the complexity structure that was originally developed for the Italian text. Here we can see an example, for example, of the syntactic annotation of a sentence in the two texts. The English translation of this would be Ziggy, which is the main character of the story, wants to visit all the planets. And here you can see that the syntactic annotation was matched, of course, in the face of the differences between the 2 languages, but a remarkable effort was made to align the most the 2 texts. And when I'm speaking about increasing complexity, we can see that, for example, at the word level, at the lexical level, words were longer on the first upper plot. We can see that across episodes on the x-axis, while word length on the y-axis, and we see that words, content words in this case, were slightly longer in the later episodes. They were less frequent, and the lexical density, which is the ratio between content and functional word, decreased across episodes. Similarly, at the sentence level, we have longer text in the later episodes, longer sentences, and the dependency length was made longer. So that syntactic relationships that we're already familiar after the wonderful talks yesterday about UDs were increased, so that the syntactic complexity increases as well in the later episodes. Now we can see some preliminary results. I forgot to mention before that after each text, the children were provided with some questions in order to assess the comprehension. And we can see on the bigger plot, the Bulgarian, on the smaller plot, the Italian kids, that they, especially Bulgarian kids, apparently read more deeply the text and reach ceiling level almost already from the 2nd grade. The color code stands for aloud and silent reading, as all the children read twice different text, the first aloud and the second silent, or vice versa. Again, reading conditions were counterbalanced across participants as well. Going to the tracking time, therefore the time spent by the reader underlying each word in the text decreases across grades. And again, we have grade level on the x-axis, the tracking duration on the y-axis, color code for aloud and silent reading, and we can appreciate this decreasing pattern both for Bulgarian and Italian readers. I want to show and highlight here the difference between aloud and silent condition that do not appear in the 2nd grade, as the t-test is not significant. The same for Italian. It means that even when reading silently, the kids somehow articulate internally, and they do not distinguish different strategies that instead for adult and more mature readers are at stake when reading either silently or aloud. Here we see some modulation, some benchmark effects regarding word length. Again, we have color code for grades, loud and silent on the two sides of the plot, bigger plot for Bulgarian, smaller plot for Italian kids. And again, we see how the longer the word, the longer the duration of the tracking. And this effect was much stronger in the second and the third grade than in the fourth and in the fifth. And again, the pattern was very similar in the two population, Italian and Bulgarian. Similarly, the word length, the word frequency. Again, we have a reduction of tracking duration for more frequent words, and the effect being more pronounced for younger readers. And here, in order to compare the frequency coming from different corpora, of course, for Bulgarian and for Italian, the Bulgarian national corpus was used to assess frequency of Bulgarian words, while in Italian, we used Subtlex, which is a corpus made up from movie subtitles. But again, and the zip scale, which is a standardization of the raw counts of word frequency, can be used to compare different frequency measures from different corpora. And we see again that the modulation was pretty similar in the two populations. So, summing up the result, we saw that children correctly read and understood the text. We also observed a reduction of reading times across grades. Silent reading resulted in shorter tracking times than allowed reading from the third grade. And finally, a stronger effect of word length and frequency in lower grades. And I think it's very interesting that similar results were observed for both Bulgarian and Italian children. Of course, this is just the starting point of our project. The speech-to-text analysis is what we will do further. We have already the tool to align Bulgarian speech, to transcribe the speech of Bulgarian kids to the text and try to replicate the results that Vito showed regarding eye voice and finger voice span with Bulgarian, and therefore come up to more fine-grained analysis for different linguistic levels and explore the multimodal interaction between voice recording and finger tracking. And that's it. Thank you for your attention.